all quadratics tied together for us. So we can solve them by factoring. We can solve them by quadratic formula. We can solve them by graphing and finding the x-intercepts. We can solve them a lot of different ways. And that's like the whole point of quadratics. Okay? So reviewing, solve by factoring for us means factor. Some of you missed the part where it says solve on your test. So that needs to be, I know, I just said it. It's fine. X minus 4. Some of you just had a gasp. Okay? Yeah, there's a few of those. Like, it says solve for X. You've missed half the point here. Oops. Anyway. All right. We are not going to use our calculator to graph. We are just going to graph from this because we don't need our calculators. Okay? So, here we go. If you factor and solve, you get x equals 4 and x equals negative 3. Why do I not need my calculator? Because I've found the zeros. I am smarter than that. So this gives me an x-intercept at 4, and it gives me an x-intercept at negative 3. And if I remember anything about quadratics, I know that this quadratic opens which way? Up. So it would look something like that. Yes? So how do the zeros of the parabola compare to the solutions from number 1? They are the same. So all you need to know, if you are asked to find the zeros, the x-intercepts, the roots, the solutions, they want you to find the x values. It could be the x-intercepts. It could be solving by factoring. It could be solving by quadratic formula. Pick your method. You're going to solve it. Okay? So take a minute. This says find your x-intercepts. This one says find the roots. If we don't have a calculator, what's going to be your method of choice? Factoring first, always. So take a look at these 4 questions and see what you can factor. All right, so 3 of these I can factor and solve. These give me nice x-intercepts, whether they're fractions, whole numbers, whatever. If I cannot factor and solve in B, what's my other options?
Complete the square.
I could complete the square. I could quadratic formula. Most of you would choose quadratic formula, right? It just means that I'm not going to get fraction answers or whole number answers. I would get something with a square root in it, maybe something with an I in it, depending. But I'd have to kind of think about that, okay? I don't really want to go through quadratic formula and all that right now. Know that that's how you would solve that. We don't need it to move on. Okay? We all okay with that? All right, flip the page. Let's talk about graphing. All right, so we are starting with graphing parabolas in vertex form. Vertex form is our preferred form. This is the one that it looks like up here. The reason we like vertex form is because it goes with all the other transformations that we know how to do. If you know the parent functions, you can move them left, right, up, down, stretch, or reflect, and you can draw a very quick graph. The point is not to draw like 15 different points on this. It is to give me, on quadratics, at a maximum 3. That's all I need. So the parent function we know goes through 0, 0, and then 1, 1, and negative 1, 1. This is our parent function quadratic. However, if we add in some different details, we can transform it to be a little bit different. For example, if a is a positive number, we know the parabola opens which way? Up. If a is negative, the parabola opens down. Okay, now do we remember about the a value being a higher number or like a fraction? What does the higher number do to it? Makes it skinnier. The fraction makes it wider. Okay? Now we're going to talk about that. Okay? And we're going to call that a value, if you want to write it down, we're going to call that a value a quote slope. Okay, I call it quote slope because it only works for 1 point on either side. It does not work past the 1 point, but it's enough to give us a good basic shape. So we're going to use it. Then your left and right shift. If it's plus h, which way does it go? Left. If it's minus h, it goes? Right. Okay, what about k? Positive is up and negative is down. Okay, good. You remember your transformations. All right, so that being said, we've already graphed x squared. I'm not going to regraph x squared. Let's look at b and c. All right, so before we do transformations, I want to talk about the quote slope idea. Okay? If you have 2x squared We know that that is a vertical stretch. We know that it makes it skinnier. When I say that that A value is, quote, slope, it means that you can do 1 point on either side that you go up to over 1. You may not continue out past 1 block. That does not keep going because a quadratic doesn't stay the same, right? It gets up higher and higher and higher. But you can use that as your first point on either side. And for this particular year, I don't really want you to be very detailed with this. As we go through these, you need to be able to start graphing them quicker and quicker because we want a basic sketch. We don't want a million details and the axis of symmetry and the dotted lines and all of the stuff they made you do before. I don't need that, okay? So for C, our quote slope is negative, and therefore it goes which way? Down 2 instead on either side. Now, I go through these at the beginning because the fraction ones are weird, okay? So on the next page, let's all look at the fraction ones together. We are not going to keep graphing x squared. I'm going to skip right to these two. All right. We still have no left, right, up, down transformation. Here is the wrong way to do this. The quote slope is 1/2. You may not go up 1, out 2. Okay? Remember I told you the slope only works for 1 point directly on either side. So the only way to use fraction slopes is this. Up 1/2 and over 1. You can never take that slope more than 1 block out. It will never work. You will have wrong points. Now, do I need it to be exactly 1/2? No, I need it to be somewhere between 0 and 1. Like, give me an estimate. That's all I care about. Okay, so this makes it a little bit wider. Oh, that's really bad. Connect the dots. All right, there we go. So then when I see the -3/4, I know that that means I can go down 3/4 and over 1. I might get pretty close to 1 on either side to show that I'm closer than 1/2. Another page. There we go. All right. That being said, we'll try this one more time. See if you and your people at your table can graph the rest of this page. Now, we have all of these given in vertex form. That's great because it does transformations. We can go left, right, up, down, graph them quickly. The other main, and use that, form we see of quadratics is this one. This is called standard form. We all remember standard form? Yes? Okay. Now, here is my discussion on standard form. You can handle standard form one of 2 ways. You have to be able to graph these. There's 2 ways to approach it. One is to know there's that formula, -b over 2a. What does that give me? The axis of symmetry. I really don't care about the axis of symmetry. What else does it give me? The x point of my vertex. So you could go this direction and get your x is -1. Beyond knowing that the axis of symmetry goes through the vertex and that means that you can like graph points on either side symmetrically, I don't care about it. Like I don't need you to take your time to graph down that dotted line that they used to make you do. I don't even need you to necessarily find the y-intercept. If it's helpful to you, great. If it's not, who cares? Once I have the x value here, how do I find the y value of the vertex? Plug it in. 2 times -1 squared plus 4 times -1 minus 1. This will give me 2 minus 4 minus 1. Therefore, my vertex is -3. Okay? Now, what I also want you to know, though, is this. You just had to find the vertex because it's not in vertex form. Yes? So we had to find it. It is -1, -3. Here it is. The a value, no matter which form you're in, acts like the slope. So what's my a value in this equation? 2. I can go up 2 on either side of my vertex and draw my graph. I don't need a lot of details for these. You need to be able to find the vertex, and then you need to be able to use the quote slope to find your other points. That is it. Could it help you to find the y-intercept? Maybe. How do you find a y-intercept? Just in case we had to do that ever. Okay. You can look at it on the y-axis. If you need to find it from the equation, it's always when your x equals 0. Therefore, in this form, it is always this number. Does that work out for how I graphed it? Yes, it does. Now, Again, you can go that direction, or you can turn everything into vertex form. Okay? Turning everything into vertex form requires completing the square, which makes you all immediately check out on me and say, nope, I'm not doing that a million times. Here, though, is what I have to tell you. Okay? Y'all did completing the square with saying, okay, we've got to take b, divide it by 2, square it, we've got to add something here, we've got to add something there, we've got to factor, we've got to write it this way and do this, and there were 1,500 steps. Yes? There's an easier way to think about it, okay? And I'm going to show you that, and you may very well, in fact, decide you'd rather turn every standard form into vertex form, okay? Here's what I need you to hear from me. You either need to know these formulas and be able to graph standard form the way we just did, or you need to be able to turn everything into vertex form and graph it that way. I don't care which. Does that make sense? You just need to be able to graph. That's my goal. Do we need to do another one in that form before we go to? Okay, so I'm gonna, I'll do this one just in case, and then we'll talk completing the square and be done there, okay? All right. So if I'm going the route of not changing this into vertex form, I'm going to say I need to do x equals negative b over 2a. This gives me my x value of my vertex is 3. I need to find my y value of my vertex. I plug that in. 3 squared minus 6 times 3 plus 3. What am I going to get for a y value? Negative 6. So I go over to my graph here. And I say, negative 3, negative 1, 2, 3, 4, 5, 6 is here. What is the a value? 1. So it goes up 1 on either side. Done. In this case, the y-intercept wouldn't have helped me at all because it would have been further out, and I don't really need it. I can just do this. Okay? Now, I told you I was going to show you a shorter way of doing completing the square because it is helpful to know. And if you can think about it conceptually rather than like 15 steps, it is much better for us. Yes? Okay. So let us talk about this, but you're going to have to focus with me. You're also going to have to not nod and tell me, yeah, it's great, when it's really not. Okay? So if there's questions and you have no idea, someone please be the brave person and speak up. Okay? All right, so if I want to change this into vertex form, okay, I am going to focus on 2 terms out of the 3 right here. I'm going to focus on these 2, okay? Now, you don't have to write down all this with me, so just follow and watch for a minute. 4 terms. No. Okay, so if I want to change this into vertex forms looks like x and something squared and then the k, right? I'm trying to make it go there. So what I need to do is I need to kind of force that to factor, and I actually need to force it to factor into 2 factors that are exactly the same, right? Because otherwise, I would not be able to write them as x and something squared. So if it was x plus 1 and x minus 3, that doesn't work. It's got to be x and some number twice. All right, so when I do that, rather than think to myself, I need to use all these dumb formulas, I need to think to myself, this right here tells me in advance what those numbers have to be. Like think FOIL. If I filled in x and a number twice here, and I FOILed, what would this number have to be in both of them for them to add up to negative 2 in the middle? Negative 1. Does that make sense? A negative 1 and a negative 1 when I FOIL would give me the negative 2 in the middle? Okay? Now, I don't want you to write that out. I just want you to think about that, right? So we're going to think about the fact that that 2x tells me that that's going to have to be x minus 1 squared.
So the O and the I in FOIL is?
Yes. Essentially, the O and the I in the FOIL has got to give me that negative 2x. Are we all okay with that has to be x minus 1 squared? All right, so this is another thing that I'm going to write down first for the first time so you can follow along with me. But you're going to just think this, okay? If I FOILed that out, if I did, that would say x squared minus 2x. There's my minus 2x. And what would be the third term? Plus 1. I don't have a plus 1 right there, do I? I have a plus 2. What do I have to add to that plus 1 to make it say plus 2? I have to add another 1. Yes. Oh, here's why. Okay, just hang on. this right here, FOILs out to be this, yes? Does it currently say the same thing as this whole thing up here? No, it just says plus 1. I need it to be the same as this. So if this FOILs to give me this, I need to add an additional 1 so that this gives me that 2.
So you just change the 2 into a 1 now because of that?
Okay, I didn't change anything. Okay, remember we were focusing, let me back up a step here. This is why I'm color-coded. We took and we said if this is going to factor, it's got to be factored into x minus 1 squared, right? We've up till now ignored the 2. Yes? All right. So just let's take a minute here. If this is all I have and I FOIL this, what is this? X squared minus 2x plus 1. Yes? So what we're saying to ourselves is we've taken this circled part and we've turned it into this. Okay? This does not match right now. I need it to match. For it to match, this number needs to be a what? For this to look the same as this, what does this number need to be? It needs to be a 2, right? So if this FOILs out to give me this, what do I have to add right here to make it be a 2? I have to add a 1, right? So we said to ourselves, we have to add a 1 right there to make it say plus 2, yes? So that's why it's added right here, and that's my vertex form. Okay, I'm going to pause. Okay, first, just ask yourself the question, if you took that right now and FOILed it out, would it give me the same thing as the original?
Yes, ma'am.
Okay, so if it does, all we've done is force it to factor, but it's the same thing as what's above, yes? Okay, so we're going to try it again, because it's going to take us a minute. I don't want to do the next one next, because it's got an a value. I'm going to make up another one, okay? We're going to come back to the a value in a minute. Let's say it said x squared minus 4x plus 5. Okay, so let's practice this again. Because once you start rolling with it, it actually does go very quickly. So if I just focus on these two right now, I'm saying to myself, I want that to factor into x and something squared. Based off of that negative 4 right there, what does that number in there have to be? Minus 2, right? Okay, so, because that's what would give me that negative 4x from the outers and the inners. Now, if I FOILed it all out, what would the last term say? Plus 4, but I need it to say 5. So I need to add 1. There's my vertex form. Are we seeing how that's faster? Quite a bit faster.
I explained it this way.
This is, okay, I will not take credit for this. This is a Napier thing. This is the Napier thing. She explained it to me this way. I understood it this way, but couldn't explain it this way. Miss Napier knows this one. It's much easier. A lot of people teach the textbook way, which says b over 2. Stinky. All right. Let's try it again. Okay? Follow with me. All right. Because then we have to see what happens with the whole 2 thing. Okay? So we're going to get there. What if I said x squared plus 6x plus 8? Okay? Okay, what am I focusing on?
The middle.
The middle. That's got to be an x and a what? Plus 3. Are we starting to recognize that it's always half of that?
Yeah.
Yeah, okay. All right. If I had to FOIL this, what would be the last number? A 9, but I need it to be an 8. So what do I have to do? Minus 1. Yes? Starting to get it? Yes. Let's say. Let's start with an easier one. X squared plus 3x plus 2. All right. Same idea. Let's just think about it. We focus on this. We say to ourselves, that is now going to be x, and okay, so we recognized it's always half. Yes, so what's it going to be? 3 over 2. All right, so now it's going to take you a minute, and you might have to write down just a small amount of scratch work here. If I FOILed that all out, what would be the last term? 9 over 4. But I need it to be a 2. Minus 1/4. Because 2 is 8/4, right? 9/4 minus 8/4. Still way quicker to do it this way, even with fractions. All right.
Oh my goodness.
Are we ready to take on the a values? Okay. This one. All right, now, if you did not notice, none of the ones I talked about had any A values because there's one additional step here, okay?
They were just one.
Yeah, I know. They were all one. They're easy. Okay. We're still focusing on this, okay? With one small additional step. You must pull that 2 before you think what is it going to factor into. So I think about that by pulling it out. Then I look at that and I say to myself, okay, what would that factor into?
3.
X and 3 squared. Yes? Wait. Okay, holding. Remember how we were always saying, okay, that's going to be a 9, right? Well, now that's not just a 9. What is it? It's an 18. So if it's an 18 and I need to make it a 16, what do I have to do? Minus 2. Okay? Let's look at this one. If I'm focused here, what am I factoring out? Negative 4, which leaves me x squared plus 4x. Yes? Okay, so then I go into this and I say, this is going to be x and what? Plus 2 squared, yes? All right, so if that 2 is squared, it gives me 4. Negative 4 times 4 is what? Negative 16, but I need it to be negative 12, so I have to add 4. Okay? Now, the only other thing we have to tackle is what if the A is a fraction? Here's the only thing you have to think about. Last one. Focus, focus. I'm still worried about these two. This time, what am I factoring out? Okay, now when you're factoring, do we recognize that we are dividing? Like when I factor out a negative 4 out of that 16, it's dividing that by negative 4. Yes? We don't divide by fractions, do we? By the reciprocal. So when I pull the 1/2 out, this gives me x squared plus 4x. Because it doubles that. It goes the other way. So when I force that to factor, it's going to be an x and a what? 2 squared. So then I think to myself, 2 squared gives me 4. Half of 4 is what? 2, but I need it to be a negative 2. So what do I do?
Minus 3.
Minus
3.
4.
4.
Okay?